If we see it closely, see this is how it looks like, almost similar like medulla, and beyond foramen magnum it is termed as spinal cord. Now this is derived from the caudal part of ependyma and filled with CSF. So that cavity of spinal cord is continuous above with cavity of the hindbrain, that is fourth ventricle. Now on either side you truncated cone shaped structure. Now this is termed as conus medullaris. See this. This is a trunk pia mater. This is termed as filum terminale. In newborn the spinal cord terminates, and this is L2 and L1. So at lower border of L1 at this point, or this between L1 and L2, there will be conus medullaris in case of adult. Okay. Now it's generally carried out one vertebral level below. Still one vertebral level below, for safety purpose the lumbar puncture is carried out. Now let's just see the section. So in this section what you can see is in the center there is an H-shaped area or butterfly shaped area. This is the gray matter and it is surrounded by white matter. Ventrally you can see anteromedian. Okay. See, these are the rootlets. Similarly along the posterior side also you will see multiple rootlets emerging out. See these multiple rootlets, and these rootlets will form the spinal nerve after joining to form the roots. Okay, so there are ventral root and dorsal roots which provides attachment to a single spinal nerve. Okay, the number of rootlets attached to a particular segment of spinal cord which turns into a spinal nerve, that see this is termed as spinal segment. Okay, the thickness varies from region to region. This is the dorsal root ganglion. Okay, these are dorsal rootlets, and these two together will join to form a spinal nerve segment. Deep to the T12 spinal cord will terminate. Now throughout the course the thickness, there are two enlargements, particularly from C4 to T2 spinal segments, and from L2 to S3 there is an enlargement at both the places. Now why beyond that point? Now you can see this is a bunch of spinal nerves. Okay, actually 10 pairs of spinal nerves. So beyond L1 the remaining 4 lumbar, 5 sacral and first coccygeal spinal nerves and their pairs will be lying within the vertebral canal, and these are all cauda equina. Now in the center is the H-shaped gray matter and periphery is having white matter. Now when we see the spinal cord externally, along the anterior aspect in the midline there is a fissure. This is termed as anteromedian fissure, which is anteriorly oriented, which is continuous and which is very deep inside. So it extends up to considerable depth into the space between arachnoid matter and dura matter is termed as subdural space, that is having a capillary fill of fluid. Deep to the arachnoid matter is the pia matter, the same pia matter which is continuous from meter up to S2. From L1 to S2 is termed as filum terminale internum, which is lying within the dura and arachnoid, and beyond S2 up to CO1 remaining 5 cm is termed as filum terminale externum. Initial 4 to 5 mm of terminale. Second one is sagittal, and this is dorsal aspect. Now over here this is basilar artery, which is formed by both the sided fourth part of vertebral arteries, and this vertebral arteries will give anterior spinal arteries which will merge in the midline to form a single anterior spinal artery. But this you can see in diagram, they give multiple branches and they will reinforce the anterior spinal artery and two posterior spinal arteries in relation to the dorsal root. So by and large there is formation are an example of end arteries. Now the collateral branches of this posterior spinal, so this is the skull cap, and we need the underlying brain. So let me just open it tab. So that is the importance of having CSF, and that is the importance of floating of the brain within the CSF. Now let's discuss of the blood per hour and per day you can calculate. So just imagine the functional imaging from 1.5 kg to just 50 grams. So that is the importance of having CSF, and that is the importance is on an average 1/6 of the total cardiac output. That is 750 ml of blood per minute. That is 45 liters. I'm repeating percentage of the body weight, but how much blood liters? I'm repeating 45 liters of the blood per hour, and per day you can calculate of the total oxygen requirement of the body. Okay, 20% of total oxygen needed from entire body is to the brain. Now let's overview developmentally. It is divided into forebrain, midbrain and hindbrain, or we can say prosencephalon, mesencephalon and rhombencephalon. So overall if we see, it is having cerebrum. See, this is the cerebrum. Postero-inferiorly cerebellum. See this. And here is the brainstem. Okay. Midbrain, pons and medulla. This medulla is continuous with spinal cord. Now each cerebrum is made up of two cerebral hemispheres which are connected in the midline by corpus callosum. So if we cut it open and see it from the side, see, this is how it looks like. So now you can clearly make out this is the cerebrum, cerebellum and brainstem made up of midbrain, pons and medulla, and similar thing you will see on the left side. Now developmentally, as I told, it is made up of forebrain, midbrain and hindbrain, prosencephalon, mesencephalon and rhombencephalon. So what is prosencephalon? It is nothing but made up of two subdivisions, telencephalon and diencephalon. What is telencephalon? What you see on the surface is the telencephalon, cerebral cortex and the white matter. Now the cerebral cortex is convoluted, so 2/3 of the portion is hidden inside and only 1/3 of the portion is seen on the surface. So the surface projections are termed as gyri, okay, that is a plural form, and singular is the gyrus. So single elevation is termed as gyrus and single depression is termed as sulcus. So as we can call them as gyri and sulci, surface projections and depressions. And it is just because the surface area is 2200 square centimeters and that needs to be accommodated within this brain box. So obviously it has to get convoluted upon itself to make it lateral ventricle. So deep inside you will see lateral ventricle. Now next to the telencephalon, this encephalon or the process of formation of cerebral cortex is termed as telencephalization. This is highest in human brain. So as we can say that human brain is highest in development, it is just because of telencephalon. And deep inside the telencephalon we will get a cavity. That cavity is termed as ventricle. So the ventricle or cavity of the telencephalon is lateral ventricle. So deep inside you will see lateral ventricle. Now next to the telencephalon, this area is diencephalon. Diencephalon is nothing but thalamus. And there are total 5 thalami constituting diencephalon, namely thalamus itself, hypothalamus, epithalamus, metathalamus, and somewhere over here will be subthalamus. So there are 5 thalamus together forming diencephalon, and the cavity of diencephalon, this territory, cavity of diencephalon is third ventricle. Now this third ventricle will get communicated with lateral ventricle, which is situated deep inside. This is septum pellucidum. So deep inside will be the cavity of lateral ventricle. This is the third ventricle, which is sagittally oriented. So as we have cut it open, the two halves of the ventricles are divided into each cerebral hemispheres. So this is the right half of third ventricle, which is in connection with the lateral ventricle through this foramen. This is termed as interventricular foramen or foramen of Monro. Okay, so the portion of cerebrum beyond this interventricular foramen or foramen of Monro, this portion, okay, this portion plus this entire portion belongs to the telencephalon, and beyond that is the diencephalon, this area up to midbrain. Okay, so just remember the brain, particularly the brain and spinal cord, they are having cavity throughout. Okay, and the cavities of the brain are termed as ventricles, cavity of the spinal cord is termed as central canal. They are continuous with each other, so we will get some connections between these ventricles and central canal, and this cavity or the ventricles are in connection with the subarachnoid space, which is situated between arachnoid matter and pia matter over here all around, as we have discussed. And the CSF, which is secreted into this ventricle, will get shifted from these cavities to the subarachnoid space. There is a continuous circulation of CSF and will get absorbed somewhere over here in relation to the superior sagittal sinus. So we are discussing about the formation of CSF and a specific device made up of double folding of pia matter and capillary tufts forming a specific plexus that is termed as choroid plexus. Now a portion of choroid plexus is seen in this section, so I just wanted to show you how a choroid plexus looks like. As I told you, it is nothing but double folding of pia matter containing tufts of capillaries. See this is the choroid plexus, and it is not only seen in lateral ventricle but it is also found in third ventricle and fourth ventricle. See this is how it looks like. This is choroid plexus. Now this is left cerebral hemisphere, and you can clearly make out the cavity of telencephalon, that is lateral ventricle. This is left half of the cavity of diencephalon, that is third ventricle, and the communication between these two you can clearly make out from over here. This is interventricular foramen or foramen of Monro. Okay, so this is how these two ventricles are connected. So that is about prosencephalon or forebrain made up of telencephalon and diencephalon. Next to it is the mesencephalon or midbrain. This is the least developed part of central nervous system and it remains rudimentary. So this is the midbrain. Okay, this is the territory of midbrain, and as we have discussed, all the portion of brains are having cavity inside. So this is a small cavity like a duct cavity of mesencephalon. This is termed as cerebral aqueduct or aqueduct of Sylvius. Okay, so above it is connected to the third ventricle and below it is connected to the cavity of hindbrain. So below the midbrain will be hindbrain. So obviously it connects forebrain above to the hindbrain below. So this is the cavity of midbrain or mesencephalon, that is cerebral aqueduct. Now next to the midbrain is the hindbrain. It is made up of 3 structures: pons, medulla and cerebellum. So hindbrain or rhombencephalon, it is subdivided into metencephalon and myelencephalon, the main front and cerebellum behind, and from myelencephalon medulla oblongata is developed. Okay, so this is a cavity of hindbrain, fourth ventricle, and above it is connected to the cerebral aqueduct, and below it is continuous as central canal of spinal cord, just because the medulla is continuous as spinal cord, and so as the cavity of fourth ventricle will continue as central canal. Now again, as I told you, there are choroid plexuses all around secreting CSF, so the tuft of capillaries embedded within double layer of the pia mater or tila choroidea, they are found in relation to lateral ventricle, third ventricle and fourth ventricle. So all these three ventricles are having choroid plexuses which are CSF, and there is a continuous CSF circulation. So within all the ventricles continuously CSF is secreted. Here we will get three foramina, foramen of Megendie in the midline. Projections and depressions over the cerebellar cortex are termed as folium or folium, and fissures or fissure. Like, to accommodate the large surface area of cerebral hemisphere, we need such surface irregularities and convolutions. Similar thing is applied to the cerebral cortex. So much of surface area has to be accommodated within the hindbrain below the tentorium cerebelli, and so as 15% of the surface area, 1/5, I'm repeating, only 1/5, 15% of the surface area is seen over the surface, and 85% of the surface area of cerebellar cortex is seen in the form of fissures. So it is hidden. What you see is just 15% of the surface area, and that is best seen in the section. Let me show you the section. See here the section. This is the cerebellar cortex, and you can see the fissures are reaching deep inside within the white matter. Okay, and you can see each fissure is having a portion of cerebellar cortex. So 85% of the surface area of cerebellar cortex is hidden inside. Plus it is having different lobes like frontal lobe, parietal lobe, occipital lobe, temporal lobe, and deep inside will be central lobe or insular lobe, okay, which is hidden. See this, deep inside you will get a portion of, a hidden portion of cerebral cortex. See this is insular lobe, and at the junction of diencephalon and telencephalon, somewhere over here, there lies limbic lobe that constitutes the limbic system. So this second is optic nerve. This is optic nerve. As you know, it emerges out from optic canals. So these two are optic canals, and these two will end up into the optic chiasma. So here is the optic chiasma that you know. Third is oculomotor. Oculomotor will emerge out from medial border of this basis pedunculi. There is a sulcus deep inside, and somewhere over here will be the oculomotor nerve emerging out. Fourth is trochlear. This is the only cranial nerve emerging out from dorsal aspect. Now both the trochlear nerves will wind around this basis pedunculi, and this third and fourth cranial nerve, you know, they will traverse through this cavernous sinus, and they will then pass through superior orbital fissure to enter into the orbit. Next is fifth, trigeminal nerve. It will emerge out at its junction between pons and middle cerebellar peduncle. See over here, this is a small stump. Now, as you know, it divides into ophthalmic, maxillary and mandibular nerve. So the ophthalmic and maxillary will traverse through cavernous sinus, and ophthalmic will pass through the superior orbital fissure by dividing into frontal, nasociliary and lacrimal, whereas the maxillary will pass through this foramen rotundum, and mandibular division will pass through this foramen ovale. Sixth cranial nerve, abducent. It will emerge out at pontomedullary junction between pons and pyramid over here. Again, along with third and fourth cranial nerve, it will pass through cavernous sinus, and it will leave the cranial cavity by passing through superior orbital fissure to enter into the orbit. Lateral to the abducent in relation to the olive at its junction with pons over here at pontomedullary junction between pons and olive. Here, eighth cranial nerve. Next is glossopharyngeal. So three cranial nerves, 9th, 10th and 11th will emerge out at the posterolateral sulcus between olive and inferior cerebellar peduncle. And when we see it from within, just this is how it looks like. Let me zoom in a bit. So this is how it looks like. So outermost is the gray matter. This is in the form of cerebral cortex. Then this is the white matter. You can clearly make out. This is the cavity of lateral ventricle, cavity of the telencephalon, and here you can easily make out the gray matter. Okay, that is basal nuclei. That is in the form of caudate nucleus, lentiform nucleus, and certain authorities are also believing subthalamus are also functionally as a part of basal nuclei. But by and large, you can include caudate nucleus and lentiform nucleus. There is gray matter in the form of basal nuclei, and deep inside there is a cavity of the telencephalon, that is lateral ventricle. So this is how structurally the cerebrum or cerebral hemispheres are made. Okay, see over here. Now lateral to that, this is the orbital surface divided by H-shaped posterior surface. Let me show you section of posteriorly by upper border of the pons. So this is the outline, and let's see the structures found within this fossa. From before backward, this is tuber cinerarium and infundibulum, part and parcel of hypothalamus, particularly the infundibulum. When it passes through diaphragma cell, it is continuous with neurohypophysis. Posteriorly, you can see two small sessile structures. They are supplemented by two gracile and two cuneate tubercles. Now next boundary is a roof. that is slopy, that is formed by two slopes, superior and inferior, that is stand shaped. Superior slope is formed by superior medullary vellum, inferior by inferior medullary vellum. And let's first understand the formation of roof in a diagram. So here is a roof which is stand shaped. It is made up of superior and inferior medullary vellum. The superior medullary vellum is a thin sheet of white matter and bridging the gap between the foramen of Hlushka. And this is the choroid plexus, T-shaped, and sometimes the horizontal limb may bulge out through this foramen of Hlushka. Trochlear nerve, storms of trochlear nerve. See this. Now trochlear nerve is the only cranial nerve emerging out from dorsal aspect of the brainstem. And once they emerge out, first we will cut the brainstem so as to separate the brainstem with the cerebellum. So I'm cutting the midbrain from crus cerebri. These two are the mammillary bodies, and this is what we have discussed in base of the brain. I am nearer to the optic tract. Here I have separated this. As you can see the cerebellum. So here will be the vermis, and deep inside will be lingula and nodule. That is what we have discussed. These two are cerebellar hemispheres, and there are three cerebellar peduncles that connects the brainstem with the cerebellum. So here this is the middle one, middle cerebellar peduncle on other side. And this is what we have seen, floccules and all this we need to preserve. Again, you can appreciate the cerebral aqueduct. So deep inside will be the fourth ventricle. So we need to cut everything piece by piece. So let's try to remove this cerebellum so as to expose the fourth ventricle from behind. This is today's topic, but I wanted to show you, this is a pineal gland. So here it is very much soft, delicate, but it is preserved. So as I wanted to show you, these two are superior colliculi, these two are inferior colliculi, part and parcel of princess. And deep inside will be the ventricular cavity. Here will be deep to it will be the inferior medullary vellum, and deep to it will be the superior medullary vellum. You can see two inferior cerebellar arteries, their branches, and they are, as we have discussed, they are forming choroid plexus. Okay, so this is the choroid plexus. See this with the inferior medullary vellum. This is nodule, and this is how the choroid plexus looks like, vascular fringe. On either side, these are the vessels, and this is what I wanted to show you is in the center, as we have discussed in diagram. This is inferior medullary vellum, and in the center, in lower part, you can appreciate foramen of Magendie, through which the CSF will drain out into the cisterna magna. So this is foramen of Magendie, and deep inside will be the ventricular cavity. See this. So these two are lateral dorsal recesses. Here will be the lateral recesses, and this is foramen of Magendie. Here will be the median dorsal recess, inferior medullary vellum. Can you see this? Deep inside, very thinned out. It's a single layer of pia mater which is left right now. Wait, very thinned out inferior medullary vellum. So here is the inferior medullary vellum, very thinned out. And here this is the lateral dorsal recess, lateral to this median dorsal recess. So deep inside will be the median dorsal recess. And here will be the lateral recesses and foramen of Hlushka. So here laterally, deep inside, we will get foramen of Hlushka and lateral recesses. Now next to the roof is the floor, and this is the floor all around bounded by peduncles. And let's first understand the floor in a diagram. So here in this diagram, it is to show you the floor or rhomboid fossa. Now there is a median sulcus dividing the entire floor into two equal halves, and each individual half is further divided by another sulcus. This is termed as sulcus limitans. So this is median sulcus and this is sulcus limitans. This will divide the floor into different parts. So each half is termed as medial and lateral area. This medial area is elevated. This is termed as medial eminence, and this lateral area is termed as vestibular area. Now developmentally, this medial eminence is derived from basal lamina of the neural tube. And here, this is how the floor looks like. Now let's just again revise what are the structures seen in the floor. So this is the median sulcus. You can see medial eminences